So we've got y equals 2x squared plus 4x minus 6. We're going to graph this without our calculator and figure everything out. Okay? First of all, can you tell if it's going to open up or open down? It's going to open up. If we want to find the intercepts, there are two kinds of intercepts. There are x-intercepts and there are y-intercepts. Now from last year, how do you find an x-intercept algebraically? Okay, you don't remember. How do you find an x-intercept algebraically? All right. So one of the things that's going to happen this year is you're going to get to the point when if someone says find a y-intercept, your brain will immediately say make x equal to 0. Because if you think about a graph, here's my y-axis, here's my x-axis. Does it make sense that every single point on here will always have an x-coordinate of 0? So if we want to find a y-intercept, we make x equal to 0. What's going to happen for every single x-intercept? What's in common? They all have a y-coordinate of 0, no matter where you put it. I know. So when you want to find an x-intercept, you're going to make y equal to 0. We'll start with the y-intercept since it's easier. Look at your equation. We've got the equation y equals 2x squared plus 4x minus 6. If you make x equal to 0, 2 times 0 squared plus 4 times 0. You got to really know your 0 times table for this. Okay. Negative 6. Something you should practice before bed every night, your 0 times table. Build up your confidence.
Times it by 0, it's 0. If you times it by a positive number, it's 0. If you times it by a negative number, it's negative 0.
Now the x-intercepts are going to be a little bit harder because when you put in 0 for y, we get our whole last unit. How do we solve this quadratic equation? It's already equal to 0 without a calculator. No, no calculator. No, you can't go to apps.
You take 2 out of the GCF and then...
You can first take out a greatest common factor of 2. Good. X squared plus 2x minus 3. Is that easy to factor?
Yes.
X and x. 3 and 1. 3 would be positive, 1 would be negative. Split it there. X could be 1 or x could be negative 3. There are our x-intercepts.
Who decided it was legal to have 2?
Well, the thing is, when you draw a parabola, which is U-shaped, we know that this is going up, right? There's my parabola. This parabola could be over, see, it could be, whoa, I didn't want that to happen. It could be, come on, there we go. It could be there. How many x-intercepts does it have? 2. That parabola, I could move it up over here. How many x-intercepts does it have? 0. We learned about that yesterday. What happens when we have no roots? The discriminant, remember that b squared minus 4ac from yesterday? If that discriminant is negative, you get a square root of a negative inside your quadratic formula, and you can't take a square root of negative. Every time that happens, your quadratic graph, quadratic function, will look like this. It won't touch the x-axis. There's going to be some times where this parabola comes down and just touches your x-axis right at the vertex. Then it only has one x-intercept. What happens with our b squared minus 4ac when we only had one answer? It's equal to 0. So those are all things from yesterday's class that we learned, and they're connected to what's happening with our graph. If your b squared minus 4ac, if your discriminant is a positive number, then we got two answers. And anytime we get two answers, that parabola is going to be going through your x-axis twice. But no matter where I draw this and move it around, I will always get one and only one y-intercept. So far, though, what do we know? We know that it's going to, I'm just going to delete my graph so far. We know that it has a y-intercept of minus 6. 1, 2, 3, 4, 5, 6. We know that we have x-intercepts at 1, right there, and negative 3. Those are the 3 points that we have so far. We need to find our coordinates of our vertex and our equation of our axis of symmetry. I'm actually going to switch these two around. I think it's easier to find our axis of symmetry first. Where can I draw a dotted line straight up and down so that the 3 dots that I have will be at least hopefully symmetrical? Oh, nice. Oh, that did not work at all. I could group it, or I could just take out my dotted line. I'm going to make a new dotted line here. New dotted line with arrows on both sides in red. Save that. Nice. There we go.
It's not straight.
It's straight enough. Are you telling me it's not straight? Yeah, it's a little crooked. Okay. Everybody who's OCD, there we go.
Still not straight.
So where will the middle be between,
Probably
In the middle of
Stop.
right there?
No. Left. Yes.
Yeah? Isn't that 2 away there and 2 away there?
Oh, what the hell does the dot do?
I didn't do the little ticky mark here, but there would be one right on your x-axis.
It's too small.
That is too small. So there's our axis of symmetry. We label our axis of symmetry because it's straight up and down. This is going to be a little bit different than what you might think. You might want to say y equals, but it's always going to be x equals, for the same reason that any point that I put on that line will always have an x coordinate of what? What will be the x if you pick any point on that line there? It'll always be -1 for the x coordinate. That's why we label our axis of symmetry with an x equals -1. Our vertex is always on our axis of symmetry. So we found our axis of symmetry. That was number 3. We found out that that was x equals -1. But now that we've found that, we'll be able to do number 2 and figure out what our vertex is. Because what do we know about our vertex? We know that the x value has to be -1. It's got to be on that dotted line somewhere. All you have to do is plug in -1 into your equation. So if I go y equals -1, well, there's a 2 first, 2 -1 squared plus 4 -1 for x minus 6, what do I get? Order of operations, we do the -1 squared first. That'll be 1. 1 times 2 is 2 plus -4 minus 6. To get -8. That tells us When x is minus 1, y is minus 8. On our graph, we now have another point. We are at minus 6 here, 7, 8. There it is. Minus 1, minus 8 is our vertex. I can go back down. We now have lots of information on our graph. We have our vertex. That's a very important point. We have our axis of symmetry, and we have our x-intercepts. We know since the number in front of x squared is positive that it's opening up, and we know that this vertex is going to be our minimum point. We can now draw our parabola U-shape as best as we can. Chris, you might have to practice a couple times. And we have our parabola, because we know that our minimum is at that negative 1, negative 8. We know that it's going up. We've got our x-intercept, so it has to go through those points. We've got our y-intercept at minus 6. We know it has to go through that point as well. The domain of the function. This is one of the easiest questions because it's always going to be all real numbers, so we can say that any number for x is possible.
Including negative 0.
Any real number is
Negative
possible.
0 is real.
And for 5, we highlighted before that the range is dependent on the vertex. Can you see for your y values, if this is my y-axis going up and down, I have no y values at negative 9. Negative 8 is the minimum y value that exists. So for our range, the y values only exist at negative 8, and you see how my graph goes up forever? They only exist from negative 8 and higher. How do I write that? Y has to be greater than or equal to negative 8. So that's how we can write the range. That the y values are always bigger than or equal to negative 8. This is called set notation when you write it this way. You can also write the range in interval notation. Did you learn interval notation last year?
I don't know what that term means.
Okay. This y greater than or equal to negative 8 can also be written like this. All right, let's explain that. I'm going to erase some of this for now. The first number is always your lowest number. The second number is your highest number. Yes. Wow, that looks like number.
Forgot the R in the other one.
I did forget the R. Number. This square bracket means that that value is included, and a round bracket means not included, and you never include infinity. So whereas y is bigger than or equal to negative 8, that is saying that start at negative 8 and keep going on forever, bigger than that. This says the same thing. Start at negative 8, that's my lowest number. Keep on going, and the infinity sign means keep on going forever. XER can also be written in interval notation. What would the smallest number be? Andrew, you're going to like this.
Negative 0.
Close. Negative infinity. Also something that really doesn't exist.
We should give Andy a limit to how many negative zeros he should.
How many negative zeros in a class?
3, I think so. Infinity. Negative 0 times, yeah, what you get.
So, The questions you can do from this one are 4, 5, and 7.